All right, chapter 5, section 1, like I said, we're only going to do half of it today. Exponential functions. The exponential function f with base a is denoted by function of f of x equals a to the power of x. Okay, in the next few slides, the base is going to be labeled as b. Just know the number in front of the exponent is considered your base in this case. Okay, so most important thing that you have to know is that your base is a, but in the next few slides, it's going to be written as b, okay? With your base, it must be greater than 0, and it cannot be 1. That's what this means right here. Your base must be greater than 0, but it cannot be 1. So, showing you an example of what an exponential function looks like with some values. I can have 2 to the power of x. Okay, why? Because 2 is my base. It's greater than 0, but it's not 1. I cannot have 1 to the power of x. This is a no. This cannot happen. It's unacceptable. Okay? Unacceptable. Do not have 1 as your base. Do not write it as 1. It cannot be 1. Do not write it like that. Again, the number, I need you guys to understand, the number can be greater than 0, but not 1. So what could it be? I could have a fraction. I know we don't like fractions, but I could have a fraction that could be one of them. Okay, that one works. I can have 3. I can have 4. I can have 2 over 5. It could be a fraction, but it cannot be 1. That's something that most people don't understand. It cannot be 1, and it must be greater than 0. All right, graphing exponential functions. These are what it looks like when I'm graphing. There are two things that I have here. This is a growth, and this is a decay. Okay, looking at my growth, it goes up. Looking at my decay, it's obviously going down. Something you have to know here is when you're graphing an exponential function, in this case, it will never pass the x-axis. Okay, it's going to get super, super close, but it cannot pass the x-axis. So again, when I'm graphing, or if you are graphing this on your quiz or on your upcoming test and upcoming quiz, and you decide to graph it and it goes past the x-axis, you're going to get points off. It cannot pass the x-axis. What else do I have to have? On your graph, you have to have 2 points. Okay, what are those 2 points that I can have? All right, looking at it, going over it again, 2 points that I have to have. 1 point, most likely you're always going to have is 0, 1, okay? Keep in mind if you're looking at it, regardless if it's a growth or a decay, I have this point right here, 0, 1. That is graphed for both of them. And then another graph I can have is 1, comma, b. B meaning, like I said before, my base. All right, so with the growth, something we have to know about growth means my base must be greater than 1. And I understand it's not going to make any sense right now, but once we start plugging it in, you'll kind of see the graph clear. So when I'm dealing with my growth, my base, okay, so base in this case, like I said, is b, must be greater than 1. And once we start plugging stuff in, you'll see that curve. Okay, they're both going to have some sort of curve. It just depends on the direction it goes in. So 2 points that I should have. 0, 1, and 1, comma, my base. Whatever my base is, that's what I'm going to plug in. Now, looking at my decay, this is when my base, understand this, is greater than 0, but less than 1. Okay, that's when my base, again, greater than 0, but less than 1. That's my fraction. Okay, that's my fraction, or negative exponent, depends what I have. But again, if you plug information in, okay, if you plug something in and solve it, you'll graph the points and you'll see where it goes. But for you to know kind of where the graph goes, if you're looking at and comparing your growth and decay, it has to do with the base of the number. All right, looking at number 1. let's go ahead and find a couple things. Does anybody know what my base would be here? Good. My base in this case is going to be 2. So let me grab my pen. I'm just going to write my base. Oh, we can't see that. Let me grab a darker color or a brighter color.
Use orange.
Base. Thank you. I will use orange. My base. Can we see that? No. Okay. Let me. I'll use like a white orange. Like a. Okay. Base is 2. Okay, so my base is 2. So what is that telling me about the 2 points I have to have? Remember, 1 point I'm going to have is 0, 1. So putting a dot at 0, 1 right here. Okay, my next point that I'm going to have is going to be 1, comma, my base. And what is my base? 1, comma, 2. So I have 1, comma, 2. Again, we have to know how to graph. So kind of looking at it, I'm going to have a growth, but I kind of want to fill in more points. Again, I have to have 2 points, so at least these 2. If you want to kind of guesstimate where your graph is going to go, remember, it's never going to cross, or at least in this case, it's not going to cross your x-axis. So it's going to look something like this. It's going to get super close, and then it's going to curve up. So let's go ahead and find more points just to make sure my graph is as accurate as possible. So how am I going to find more points? I'm going to go ahead and draw a t-chart. So here is my chart. I have my x and I have my function 2 to the power of x. So we already did 0. We already did 1. Where did I do 0 and 1? Right here. But just so we know, I'm going to plug it in. If I use 0, what's 2 to the power of 0? 1. So that's where I'm getting my coordinates. 0, comma, 1. And let's just go ahead and do 1. What's 2 to the power of 1? That's going to give me 2. So again, that's where I'm getting these coordinates. 1, comma, 2. Let's just go ahead and plug in some more to make sure my graph is a little bit more accurate. So let's use 2. What's 2 to the power of 2? 4. So I'm going to go ahead and go to my graph. And I'm going to go 2, 4, 1, 2, 3, 4. About where I guesstimated. Okay, looking at the next one, let's do 3. What's 2 to the power of 3? 2 times 2 is 4, and 4 times 2 is good. So again, right here's 4, 5, 6, 7, 8. So it's just a little bit off, but we can go ahead and fix that. Again, I at least need 2 parts. Okay, I at least need 2 points. So I can just continue it from right here. And let me grab my red and continue, okay? Now that I do have, a lot of my points on that side, let me go ahead and I'm going to show you that it never, or it's in this case, not going to cross your x-axis. You have that, it's called an asymptote, okay? It's not going to cross. So looking at it, I'm going to have negative, let's do negative 1. So what's 2 to the power of negative 1? We have to go back and remember our rules of exponents. Does anybody remember that rule? What do I do if I have a negative exponent? What's going to happen? All right, what's going to happen is you're going to have to flip it to make that positive. So flipping it, I'm going to have 1 over 2. So now my coordinates for this point is going to be negative 1, comma, half. So about right here. Once you get into fractions, it does not have to be exact. Okay, now let's go ahead and try negative 2. 2 to the power of negative 2. What am I going to get? Again, I have a negative exponent. What's going to happen with negative exponents? You're going to flip it. So I'm going to have 1 over 2 to the power of 2, which I'm going to end up with 1 over 4. Again, graphing it about right here. Okay, what if I have negative 3? 2 to the power of negative 3 is going to give me 1 over 2 to the power of 3. and that's going to be 1/8. Again, smaller and smaller, closer and closer to the x-axis. The more I plug in those negative numbers, I'm going to have to flip it, meaning it's going to give me a fraction, and it's never going to give me that whole number to cross the x-axis. So it's going to get close, 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 close. It's never going to pass at all. All right, looking at the next example, example number 2, what do I have? Same thing, looking at it, what's my base? Good, my base is going to be 3. So my base...
Wait, is it always 0, 1?
My base in this case is 3. Yes, I'm going to start with 0, 1. Okay, which is right here. And then what's another point that I could use? 1, 3. Again, just showing you why it's going to be 0, 1. If I were to, again, draw that t-chart, plug in my x, I have f of x equals 3 to the power of x. If I plug in 0, what's 3 to the power of 0? 1. Okay, so it's going to be 0, 1 for that. And then if I plug in 1, I'm going to get 3 to the power of 1, which is just going to be 3. Let's go ahead and do positive 2 and then negative 2 just to give me a more accurate graph. I'm going to have 3 to the power of 2, which is what? 3 times 3. I'm going to end up with 9. And then what if I have negative 2? What's 3 to the power of negative 2? Remember, if it's negative power, what do I have to do? I have to flip it. And then what am I going to end up with? 1 over 9. So kind of just graphing that. 2 is going to be 2, 9. This was 3, 4, 5, 6, 7, 8, 9 right here. And then negative 2 is going to be a 9th. Again, like I said, doesn't have to be accurate. Just make sure it's not on the line. Okay, so if I'm looking at it, this is what the graph is going to look like. Again, super close, but never crossing. And then going through my points. Okay, let's go ahead and go to the next slide. Going on to example 3 and 4, let's just go ahead and go over these again. What's my base here? Good, 10 is my base in this case, and which 2 points should I at least have? 0, 1, and 1, 10. Because again, it's 1 your base, and 10 is my base. So just graphing those, I have 0, 1, and then I have 1, 10. 6, 7, 8, 9, about right here. And again, graphing it, it's going to look something like this. Super close to that x-axis, curved and going through that 110. Okay. If you want to double check your points, let me actually change this curve just to make it closer. If you want to check your points, for all means, you could check your points. I could test some out. So if I wanted to test them out, I could just plug in, let's do 2 and negative 2. Here's my f of x. If I have 2, I'm going to get 10 to the power of 2. And that's going to give me 100. That's way off my graph. Let's say I had negative 2. Okay, 10 to the power of negative 2. That's going to give me 1 over 100. And again, that's going to be like super close to that x-axis. Again, it's not going to cross, but it's going to be like very, very close. Okay, let's go ahead and look at example number 4. What's my base here? Okay, is this a growth or a decay? This is going to be a decay because my base is a half. So meaning all the rest were growths, they all went this way. Now it's going to go the opposite. And again, we're going to plug stuff in to find that out. So what are some points that I have to have? 2 that I have to have. 2 easy ones. Good. 0, 1, and 1 in my base, which is a half. So graphing that right here. And then if I know it's a decay, if I go to 1 and a half, it's going to be right here. So looking at it, I can tell that it is a decay if I just at least graph those 2 points. So it's going to look something like this. but I want to be able to add some points on my negative side. So what I'm going to do is I'm going to go ahead and give myself some extra points. Because again, I want to know how wide or narrow my graph is going to be. So looking at this, my extra points, I have x, I have my f of x, 1/2 x, and I'm going to do -1. So if I have 1/2 times the power of -1, if I have a negative exponent, what do? Flip it. I'm going to get 2/1, which is just 2 as a whole. So at -1, I'm going to have 2. And then at -2, 1/2 to the power of -2, I'm going to end up with 2/1 to the power of 2. And I'm going to get 4 as a whole. So this is what my graph is going to look like, something like this. Again, never crossing that x-axis. So I have on this slide a growth and a decay. All right, looking at example number 7. Now pay attention to this one. Looking at it, my base is, in this case, it looks like it's a whole number, but when we're graphing it, because of that negative with the exponent, it's going to change. So I could change this base to make it easier for me. If I have a negative exponent, what do I have to do? What do we have to do if we have a negative exponent? You have to, what? Flip it. So I am going to change this. I'm changing it to 1/2 to the power of x. Okay, I can change that. And again, if you take what they're giving you and plug in numbers, you're going to see why we're flipping it. So this is going to be a decay. So looking at it, what 2 points should I have? I'm going to have 0, 1, and 1, 1/2. And again, if you're like, oh, but the base looks like it's 2, let's go ahead and plug some points in. Again, drawing my little t-chart, I have x, I have my function f of x, and using what we have, let's plug in 0. What's 2 times the power of -0? What's 2 to the power of 0? I mean, can't really have -0, so 0. It's going to be 1, so I'm still getting that 0, 1. Now, if I'm using 1, what's 2 to the power of -1? What am I going to do with that negative power? I have to change it, means I have to flip it. So I'm going to again get 1, 1/2, all because of that negative right here. So you can plug in information just in case you're unsure, or you could kind of know some of the rules. So let's go ahead and find a few more. Let's just go ahead and do -1 just to get 3 key points, one on the positive side, one on the negative side. So I'm going to get 2 to the negative power of -1. What is that going to give me? 2 to the power of 1, and what do I have for 2 to the power of 1? It's just going to be 2. So at -1, it's -1, 2. So graphing the points that I should have. 0, 1, which is right here. 1.5, 1, which is right here. And then -1, 2, which is right here. So again, what should my graph look like? Something like this, never crossing that x-axis. Okay, again, at least 2 main points, but to just know where it goes, I recommend you do 3, at least 1 positive, 1 negative. Let's go ahead and go to 8. Let's look at this one. Plugging in information. Okay, let's just do it again. We're going to use positive and negative. X with my function, f of x equals -3x. -1. I have -3 to the power of -1. What am I going to get? If I have a negative power, what do I have to do? I have to flip it. So keep in mind it is a -3. So I'm going to get -1/3. Or you know what? Yes, -1/3. So graphing this, where would it be? At -1, I'm going to have negative a third. So that's about, again, estimating, guesstimation, doesn't have to be perfect. And that one is right here. Okay, let's go ahead and do 0. I have negative 3 to the power of 0. What am I going to get?
1.
What kind of 1? Negative 1. Remember, the exponent is just going to the 3, not the negative. So at 0, I'm now going to have negative 1. And at positive 1, negative 3 to the power of 1, what am I going to get? Negative 3. 1, 2, 3. So how do I know it's going to go this direction? We covered something like this already in chapter 4. Okay, we did transformations and reflections. Look at it. My negative is outside or in front of my base. That means I'm going to have a reflection of the x-axis. Okay, I have a reflection of the x-axis, and yes, you guys will have some sort of transformation with these. So let's go ahead and look at the next slide. Here are my transformations. So looking at my transformations again, we've covered some of these, so they shouldn't be too difficult for us. Again, we've covered some of these. So looking at it, I have a vertical transformation. How do I know I'm going to have a vertical transformation? Because I'm adding something and subtracting something. Keep in mind, we should know what this means. If I'm adding a vertical transformation, that means I'm going up the amount of times they're giving me. And if I'm subtracting, that means I'm going to go down the amount of times they're giving me. Okay, how do I know if it's a horizontal transformation? If I'm adding something to my exponent, that means I'm going to the left. And if I'm subtracting, I'm going to the right. Okay, and reflections, we just saw this on the last example. If it's outside, okay, this is going to be a reflection of the x-axis. Okay, and if I have it on my exponent, it's a reflection of my y-axis. Okay, vertical stretch or shrink. All you have to do is graph using a table for all of these, and you'll be able to see where it grows. So depending on the coordinates you use, you can see everything that happens with the vertical stretch or shrink. All right, looking at these examples, so same thing as before. What does this negative 2 mean? What does this negative 2 mean? I'm going to have some sort of transformation, okay? And hopefully we know from previous lessons that I'm going to have a vertical shift. I'm going to have a vertical shift going down 2 units. So if you know, hey, my base is 3, I know 3 key points. Those 3 key points are going to be 0, 1, and 1, 3. All you're going to do is take those points and shift it down 2 units. 1, 2, right here. 1, 2, right here. And also think of the x-axis as I'm shifting it as well. Okay, what does that mean, shifting the x-axis? That means you cannot cross this line right here. So think of that as my new x-axis. You just can't shift it, because if I were to draw 3 to the power of x, if I were to draw that function, it would look something like this. Keep in mind, I'm not passing the x-axis. All I'm doing is shifting it down 2 units, so I still cannot pass it. So because I still cannot pass it, again, it's going to look something like this. It's going to get super, super close, but it will not pass. Okay, super close, but it will not pass. Again, if you want to check it, you can check it. You can plug in some points. So looking at it, here's my t-chart. I have x. I have my function. Keep in mind, this is considered my parent function. That's 3 of x. And those 3 points were 0, 1, 1, 3. And again, all I did was shift it down 2 units. So let's see. If I have negative 1, 3 to the power of negative 1 minus 2 is going to give me a third minus 2, which I'm going to end up with, what, 5 over 3. It's about like 1 1/3. Okay, if I'm looking at 1 1/3 at -1, I'm going down 1 and here's my third. So that's about right here. Okay. And then if I have 0, I have 3 to the power of 0 minus 2. I'm going to get 1 minus 2, which is going to give me -1. So at 0, I'm at -1, which right there we graphed it. And then at +1, 3 to the power of 1 minus 2, I'm going to end up with 3 minus 2, which is just a +1. And again, right here. So you can see, just with that shift, all I'm doing is moving down 2 units. Now my horizontal asymptote, that line, is going to be where y is at -2. Okay, that line is at -2. That is now where my horizontal asymptote is because they're giving me that -2 here. Okay, so that, again, that means it is not going to pass that line where y equals -2. All right, let's go ahead and do example number 10. Same thing, but now looking at it, my exponent, I'm subtracting 2. This is now, I'm shifting 2 units to the right. Okay, horizontally 2 units to the right. Again, we know that parent function, that was 0, 1, and then 1, 3. I'm moving 2 units. So moving 2 units to the right, that's right here. Moving 2 units to the right, that's right here. And again, I'm still not crossing that x-axis, and I'm curving up. So I'm still using that same x-axis and curving up. All right, 11 and 12. Let's go ahead and do that one as well. So looking at this, same thing. Okay, looking at my exponents, because I have that -2, I'm shifting 2 units to the right. My parent function was where 4 to the power of x. Okay, 4 to the power of x. So those key points are 0, 1, and 1, 4. Just graphing those really quick. Hold on, 0, 1, 1, 1, 2, 3, 4. Shifting it 2 units, 1, 2. 1, 2, and graphing. Looks something like this. All right, let me go ahead and do the last example, looking at number 12. Okay, now this one still has that parent function of 4x, but now in this case, I'm going to move up 3 units. So if you're looking at it, you're going up 3 units, and again, that parent function was 0, 1, 1, 2, 3, 4. And then all I'm doing is shifting it up 3. 1, 2, 3 right here. 1, 2, 3 right here. And don't forget, your horizontal asymptote is also shifting 3 units up. 1, 2, 3. That will make it right here. So that's the line you are not crossing. Right now my horizontal asymptote is where y equals 3. And drawing that graph. Okay, again, does not pass that line, but it's going to get super close, and then continuing. So these have shifts.